Okay, hello. So these are your video notes for tonight's homework. So you want to go ahead and title this Unit 3, Lesson 24, Work Rate Problems and Rational Equations, okay? Now, we've been working with a few of these work rate problems, but I wanted to highlight more specifically about work in terms of rate, okay? So here we have this formula where work equals rate times the time, okay? So whenever we're referring to any of our work problems, we're really referring to the rate, okay? For instance, we could say that W equals R times T, right? But usually what we've been seeing in problems is that the work represents the one job, okay, it represents the one job, and the rate it was usually represented as a fraction in terms of how many hours or minutes a person can complete that job, right? So this was more of a what was I saying? As a fraction for this one. And then, and usually, and I'll explain where that fraction came about. And then we are comparing it with the time, right? So the rationale behind all of this is that we want to figure out generally what is the rate, or we want to see what is the total time adding their rates, right? So the key thing that we're going to focus on this equation is identifying the rates. So in this case, what we could have done is having this variable isolated. So I could do rate divided by t on both sides, and the t's will cancel out, and we'll get 1 basically, and we'll get r is equal to work over time. Okay, so that's essentially what we're doing when we are comparing the work that each person is doing in a problem, okay? So let's go in more specifics. This is more of like theoretical piece and where this means, okay? So for example, 1, we have 2 characters from a novel. So we have, suppose Huck Finn can paint a fence in 5 hours. Oh, that should say 5, or in 5 hours. Tom Sawyer can paint the fence in 6 hours. How long will it take them to paint the fence together? Okay, now I'm only going to show this once to you just to show you why the formula that we've used before, the job over time, for instance, job over time plus job over time equals the one job over total time. Okay, I'm going to show you why that makes sense, okay, with this example here. So let's just say that we have a chart. No, I do not want you to do this chart multiple times for all the problems that you'll see on your homework or anything like that, because you all are very skilled at this. This is just to help us understand why this formula makes sense and why we are using 1 over something, okay? So here I'll make this, and then, okay, I think that's it. So here we can say this is rate, and this is time, and this is work, right? So I'll make this like, this is work, this is time, and this is rate. Okay, so we have 2 characters. We have Huck, and we have Finn, or not Huck, Finn, we have Tom. And then we want to figure out what is the total time that they can complete painting a fence together, right? So they're essentially doing the same time or the same job, one job, painting the fence. So Huck is doing that one same job, and so is Tom. And we want to figure out what is that, what will be the total time that they will take to do that same one job, right? Now we know for Huck, explicitly says here that Huck can paint a fence in 5 hours. Okay, so then I know that what I can write here is that is 5. So he can paint that in 5. And then I can say for Tom Sawyer, he can paint the fence in 6 hours, right? So then we know that's going to be representative in our chart, 6 hours. We don't know the total time that they have the fence, or how long they take to paint the fence for together. So we put X for together, right? Now, see how this is rate? Rate is equal work over time, right? So that's work over time. So essentially, work over time. So in this case, this is Huck's rate. It's 1/5. So he can paint the fence 1/5. Or the way you say this is he can paint 1/5 of a fence per hour, right? And then same thing for Tom. He can paint 1/6 of a fence per hour. And we want to figure out how the total time it takes for them to paint the fence over the per hour. Okay, so then the way we focus on, this is how that equation came about, is we were going to focus in on just this column, right? So all of this, and that's how our equation started out, right? So then what we can say here is we can set it up that we can say for Huck, right? For Huck, we can say that his rate is that he can paint a fence, he can paint 1/5 of a fence per hour. Paint 1/5 of a fence per hour. And we can say for Tom, he can paint 1/6 of a fence per hour. Okay, so we want to figure out, again, the total, which is represented as 1/7. So what you have been seeing before is we have 1/5. The way you set this up is 1/5 plus 1/6 equals 1/x. Okay, and then you could find how much time it takes for both of them to work together. But the way I'm going to represent this, so that way we can continuously flow with the next problem, is I'm actually going to remove that variable from the bottom by multiplying it times the reciprocal. Okay, but first I should also identify the time that they work together is represented by x. So let x represent the total time to paint fence. Okay, so then from here, I'm going to do mostly this algebra piece. So once we have this set up, I want us to go ahead. Like I said, you could just get a common denominator, get 30x, and go from there. But I'm going to multiply this times x. Okay, so I'm going to multiply. I want to get rid of my variable on the bottom. And whenever we want to get rid of something that's in the denominator, we just multiply it times the reciprocal. So it's just essentially times x, or x/1. Right? And then I'm going to distribute that to each one of these, right? So I'm going to distribute it to the 1/5, and 1/6, and 1x. So then I'll get 1/5 x plus 1/6 x equals 1. And essentially, this is the same equation, except we are now more clarified at the idea, like, okay, we're completing one job, one outcome. So, okay, so then at this point, we just need to solve for x. And remember, we just want to find the total time. So then from here, we can rearrange this. This is, remember I said in our class that 1/5 x is the same as writing it as 1/5 times x/1, which is the same as x/5. So that's all I'm going to do right here. So right here, I'll get x/5 plus x/6 equals 1 over 1. Now we can use our least common denominator, and our least common denominator is 30 in this case. And there's many ways that you all can do this. You can use the property of one way, or you can just change all of these to have a denominator of 30 and then rewrite the numerator. That's the way I'm going to do it for this problem. So here I'm going to multiply the top and the bottom by 6, and then here by 5, and then here by 30 and 30. Okay, make sure, I'm going to put like a caution sign right here. Make sure you are also, whenever you're multiplying to get the least common denominator, you also have to include whatever it's equal to, right? You can't just change the denominator for the left side of the equation and not for the right, okay? So then here we'll get 6x over 30 plus 5x over 30 equals 30 over 30. And then from there you can just rewrite the numerator, and we'll get 6x plus 5x equals 30. And then we can combine like terms, and that will become 11x equals 30. Isolate our variable, divide by 11 on both sides, and we'll get x is 30 over 11. And this is representative in hours. Okay, now we can say 30 over 11 hours, or we could say 2 hours and 44 minutes. Okay. This would work, or this would work. Okay, cool. So that's just, I wanted us to practice this piece in changing our equation without having x in the denominator, okay? And the reason is it's going to make a lot more sense when we're working with problems that deal with breaks or a given break, okay? So, for instance, right below, it says Tom demands a half-hour break while Huck continues to paint. And they find Tom demands a half-hour break while Huck continues to paint. And they finish the job together. How long does it take them to paint the fence? Okay, so the key thing that's different in this problem is that we know that Tom demands a half-hour break. So Tom is pretty needy. And he demands this. He wants a half-hour break. So that's code for, we can go ahead and use our strategic reading and say like half an hour, we know that's code for 30 minutes, which is the same as 0.5 minutes, which is the same as 1/2, okay, minutes. Or we could say, I shouldn't say minutes, 30 minutes, which is the same as 0.5 hours, which is the same as 1/2 hours. I should say that. That'll be more clear. Okay, so they still want to finish the job together. So we're going to take the original problem, but that's in this form. So the 1/5 x plus 1/6 x equals 1. Okay, so this represents the 1/5 is Huck's rate. He can paint 1/5 of a fence per hour, and I'm going to represent this as x. And x represents the total time again, plus, this is what's going to be a little bit different, so I'm going to leave some space. We have plus Huck's rate with his break. With Tom's rate with his break, and then is equal to 1. Okay, this is like the key thing. So we know that Tom can paint, his rate is, he can paint a fence 1/6 of a fence per hour. So it's 1/6, right? But the key thing here is that he took that half-hour break. So what we have to do is we have to show that break in our equation. And that's going to be representative with x minus 1/2, okay? And then from there, we can go ahead and solve what was the total time while including Tom's half-hour break, but with the total time, but not to the given time that's productive, right? Because he's taking a break, so he's not productive in that time frame. So this is kind of like your setup. And this is how you are always going to set up the structure whenever you have a break. So like, for instance, if you took an hour break, you would put 1 right here, right? you'll like subtract 1. Or if he took a quarter of a break, you'll put like 1 over 25, okay? Or he took 2 hours, you put 2, right? So think of this as your structure. So then from here, we can go ahead and show this in this form. So we have 1/5, we can go ahead and solve, plus we can distribute this 1/6 to each of these. And we'll get 1/6 times x minus 1/6 times, or no, 1/6 times -1/2. So I'm going to do that on the side. So we have 1/6 times a -1/2. So then we'll get a -1 over 12. So here I'm going to write minus 1 over 12. My pen. Okay, 1 over 12 equals 1. Okay, so then from there, we can rewrite this as x over 5 plus 6 over, not 6, x over 6. So this is all the next steps. So we have x over 6 minus 1/12 equals 1, okay? Yes. Okay, so then from there, we can go ahead and we can add 1/12 to both sides. Okay, or at this point, you could just find, actually, I'm going to pause right here. So many people can see this in a different way. Some people can go ahead and recognize like, oh, like x over 5 plus x over 6 minus 1 over 12 equals 1. We can also show that this is 1 over 1, and then you can find the LCD here. Some people may like this method and go ahead and solve, and then other people may go ahead and just do add 1/12 to both sides, add 1/12 to both sides, and then solve. Okay, I'm going to let you choose your method, okay, because this is the piece where you get to be creative. So I'm going to leave space here for you to figure out how to find the value of x, okay, in your notes, and knowing that your answer should be x should equal 65 over 22. Okay, 65 over 22, which then will be about, well, this is in hours, and this will be about 2 hours and 57 minutes. Okay, so this piece, I do want you to, I'm going to be checking this tomorrow in your notebooks as well. So I want to see your work and showing how you got x equals 65 over 22. Now, again, you can be creative. This is how you are creative for this piece. Okay, be that creative problem solver. And you get to choose how to find the value for x. So here you could, some suggestions could be to find the common denominator, and then rewrite the numerator. And then another option could be to, or you're just like, I don't like that way and I like the other way. You can find a common denominator. Oh my gosh. And use the property of 1, right? Right. And then I'm going to leave this open to any other suggestions to finding x if you have that as well. So open to other strategy. Okay. Alrighty. Okay, so that is all I wanted you all to focus on, and recognizing the difference between this problem where you have to find the total time versus maybe a problem where you have to include a break, okay? So I understand this may still bring up questions in class, Like why do you have to represent it in this way that's represented in blue? So if you have a question for that, go ahead and write that down in your notes. And when I go by and check your homework, we can start that problem, or I can address that question as best as I can in that moment. Okay, well, that's it. Go ahead and write your summary on the bottom, and good luck on your homework. Bye-bye.